I started this class by explaining that IP addressing is the format, you know, of naming um, computers on a network. If I say computers, I can also mean, if I say host, I mean a client. If I say server, I can also mean uh, host, right? It's interchangeably, or in this case, just see it as a computer. Just see it as a computer. Another thing is it can be referred to as a node, right? Now, usually, if we go to how network is structured, the basics of networking. Normally, if you have a host, it will be connected to another host, and then this can be connected to another host. That connection would also have something in the middle. This is a typical LAN called a switch that is like a small hub, right? But then each of these hosts is identified by an IP address. IP address, right? Now, the IP address is like the postal address of each of them. And why did I say postal address? This switch, the function of this switch would also have its own IP address. I'm just bringing it here because of space. Every node or every host on a network must have an IP address. And the question is, how do you determine how an IP address should be, assigned? That is where the foundation of your network design starts from. It's like in this country now, we have postcode. You might have wondered, how was a postcode designed? How did they determine that house within these blocks would have a separate postcode from houses that are just across the street, right? So the postmaster general, or at one time or the other in the past, have sat down to map out the geography or the network of how they want the postal addressing system to function. So whether you are a system administrator, a network administrator, a developer, you need to understand IP addressing, because you need this basic knowledge for your troubleshooting. So let me just take a simple example of an IP address on my network now. On my network, on my network now, this is command prompt on my network, the network I'm using on my system. If I want to find out what the IP address of this system is, all I need to do is to type a command called IP. It starts with IP config, and then I put space, I put /, and I type all. All means giving me all the details of the network card. Remember last week I talked about network interface card of a computer. That is like the network, the uh, post office box of every house. Now in the UK here, every house has got a mailbox. That small window on your door that the postman drops your letter, consider it as the network interface card, just for an analogy. If I click enter, a series of information will come out from that simple command that I have run. The first one says host name. This host name is the name or of the computer. We call it FDQN. That's fully qualified domain name. Fully qualified domain name because if on a network, right? If on a network you are trying to get to this computer and I am on a domain, this should be the computer name that the DNS server will look for. I think I've said that the DNS server is the server on a network that translates IP address into domain name and vice versa. It also translates domain name into IP address. So the first information here talks about the network name, talks about DNS information, routing. It's just giving us information about the protocols that are enabled or the capabilities on the NIC card. I am using a wireless card, the wireless card on my laptop. There is also the wired feature on my laptop. That is if I want to use cable. So if you look here, you'll see that it is an Ethernet media, Ethernet card. Ethernet is a standard for networking. This is the manufacturer or the product family of the card. And then I come down and come down and come down. The most important information is this place. If you see here, you will notice it says wireless LAN adapter because I'm using a wireless card. This simple troubleshooting. What we're doing now is troubleshooting. It's usually if somebody comes to you and say, "Oh, I cannot reach my network," or I cannot reach my server or my website. It's not working. I cannot work. Maybe you are recruited as an administrator in a small organization or a company. You start from the network level. You want to find out, is that client, is that user having access to network? You start with your network troubleshooting, right? I'm laying this foundation so that we will understand how it works on a regular basis. You can run this command, open it on your own laptop and run this command, ipconfig /all, right? If you come here, you will see it says physical address. This address is what we call the MAC address. MAC. It's the address that is used to identify the network card physically. What I mean by that, it is like a label that the manufacturer puts on the device. That's why the network card on my system will be different from the network card on your system, even though they are made by the same manufacturer. It is a way of identifying products. So in the network world, MAC address is also used for communication. This is used for communication. The switch that I mentioned earlier uses the MAC address to identify destination of packets in addition to IP addresses, So if you look at here, it says DHCP is enabled. DHCP is a protocol for dynamic host protocol, if I still remember what DHCP means, it's what that indicates is it shows that if there is a DHCP server, now the DHCP server is the one that allocates IP addresses within a network. Because when we are talking about network addressing, clients or the host do not just assign network address to themselves. They have to pick it up from a pool of network addresses that are available, right? Now, the question is where is the pool located? That pool is stored in the database of a DHCP server in a network. That pool of addresses is stored in a database of a DHCP server. In the case of Azure that we are learning, it is stored in the virtual network. You remember I talked about virtual network as one of the resources that you can spin up, and that your virtual network is like your basic the basis of your networking. That is what we can refer to as LAN, right? That's what we can refer to as LAN. So that is DHCP. So what this indicates is that this machine has capability to talk or listen on a DHCP protocol, and so it's configured as yes. Then you will see here, it talks about IP version 6 addressing scheme. I will explain this later. Just let's hold this thought here. I don't want to complicate it for you now. There is also IP version 4. Now, this is the older standard of IP addressing before version 6. And the reason is that IP version 4 addressing got to an extent where the entire universe, or rather the entire world computing world started running out of IP addressing. So they had to design an addressing scheme that, would accommodate billions of devices or hosts. So IP version 6 was introduced. However, this is still actively used in my own regular work in the current setup of network within organizations. I've not seen, people using version 6 a lot, maybe at higher level. What I mean by higher level, the ISPs, but a lot of organizations are still on version 4. So put your focus on version 4 for now. Then we have the subnet masks. This is what I want to explain in this class today. How to design this, how to understand why is it 255, 255, why is it this, that. So I want to explain this whole thing in this class today, so that we will, fully grasp how IP addressing is done. Does anybody have any question? Okay, so if there's no question, we're going to continue. So now, usually, like I mentioned earlier, you will have noticed on my system that my IP address is. Did anybody catch what my IP address was? Not sure. Let me check it again. My IP address on my system is 192.168.1.191. So this is the IP address on my system. It is like the postal address to which, if anybody is on my network and wants to get any resource from my laptop, the person needs to know this IP address. This IP address can change after maybe 14, 15 days, because the DHCP server, which is my router, will usually lease out IP address that expires after 14 to 15 days, depending on how the administrator sets it up in the system, right? So just know that at the back of your mind, for security reasons, you can have IP address set up in such a way that if you set it up as dynamic, IP address, it means that it will expire after some days. Normally in the computing world, we set it at 14 days, 2 weeks. If you decide to set it as static, means it will be there until you change it. Now, for those who are interested in security, you want to avoid static IP addressing situation, because if an attacker knows your IP, that person can exploit your network for the next donkey years until you change the IP address, right? So that's that. Please, if you have questions, just note them. I'm going to take them after a while. So the question is, how is IP addressing? What exactly is IP addressing? Now, IP addressing starts. It's a way of designing your network. You need to understand your IP addressing to be able to know how your network is going to set up. And usually, I will start by saying that if you notice 192.168.1.1, for example, this first part of this number is represented as a decimal number, right? This is also a decimal number. This is decimal. This is decimal. However, in computing, because every computer works with a voltage source, if you do not power up your computer with your battery or with your power charger, it will not work, right? Computing is about running electrons, the movement of electrons, resistance, on the board, right? It's in the circuit. So your computer understands only 0 and 1 as a signal. 0 means 0 volts, 1 means 5 volts, depending on the section of where the data is being processed. Sometimes it can be 12 volts, but normally it's 5 volts. 1 means 5 volts. So though the computer has this number written as its IP address, the question is, how does the computer interpret this number? This number, the way it is written here as decimal, is just for human consumption. It's just for us as humans to be able to read it and understand what it is. Because we need to break down this number into binary. So if you still remember your binary number in elementary maths, who can divide this for me? No, I still remember. Those who are the mathematists in our midst. 192 in binary. What is it now? 192 in binary number. 192 in binary is I just want computer to help me now. If I still remember, this should be 2 into 19 is how do we divide? I can't remember now. Convert. Okay.
Somebody has dropped the response on the chat.
Okay, thank you. Someone. Excellent. Thank you. You see, we've got mathematicians. I can't remember my secondary school maths again. 1, 1, 1, 2, 3, 4. Okay, if you can convert 168 also. Oh, from ChatGPT. Brilliant. How many zeros we've got? 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so if you can also get me 168. 168 is what now? Okay, that's 1010100, right? Then 1 itself is what? 1 itself should be 000. What is 1? Is it 00001? No. Okay, let's ask ChatGPT. Can you please give me that too?
I believe one should be one
It's
because
one.
one, I
It's
mean,
one.
it's binary, right? So ones and
Binary?
zeros
It's
are
one.
valid.
Is it 1?
Yeah.
Yeah.
Okay. 1 is 1. So that is yeah, 10001. 1, 2, 3, 4, 5, 6, 7. I think it's 8. So now it means that if we're to rewrite that, what we need to write now is 000 dot 101010 1000 dot 00 and so on. So, but this format is just too long. But ideally, within the computer, this is what the computer understands. This is what the computer understands, and it interprets. This comes as zeros and one. So generally, in order to start looking at you are an administrator, the first thing you want to do as an administrator is to find out how your network is designed. If somebody else has designed it, you ask for documentation on their IP addressing, right? And usually you have to find out which class of IP addressing they have used. Now, IP addressing is divided into classes. Let me start this way. Now, the 192.168.0.1, it can be anything. It's just coming to my mind, not because I just want to change this, right? This is a different class of IP address, and I'll explain to you what I mean by class. The categorization of IP addressing is done in terms of the number of network and hosts that will be used or will be present in that network. So this is what I mean. Now, normally your network, your IP address will have a section that deals with the network aspect. What I mean by network is that, if you remember the first drawing I gave us, I said if we have hosts like this that are talking to themselves through a switch. There will now be also, like I call it the grandfather, the router that will route packets out of this network. The switch routes packets within this network, but the router takes packets out of this network in the sense in which you have another network, maybe in another building or in another state, and this is a switch. It's interconnecting all the communication. This network will have its own router, right? So this network is separate from this network. We have network B here, network A here. So put this at the back of your mind. The head of every network is a router, or we say the gateway. The head of every network, the leader of every network is a router, or we say the gateway. And why is it the router? The Americans call it the router. It's actually defined from, identifying which route or route that the packets that are coming from here are meant for. So the router normally has what we call the route table. There will be a route table here that would host different routes and their destinations, right? So that is when it comes to network design. In the context of Azure right now, in the context of Azure, where we don't have a physical router, your VNet tends to replace the function of a router. I say it with a pinch of salt because there are also other resources that are also superior or above the VNet. Like the local gateway resource is superior. When we come to networking, I will explain all of that. But I'm just trying to break down, the differences between network. And normally, if you have a network like this, where you have host A connected to another host, connected to, let's say you have 3 hosts. This is B, this is C, this is A, right? There is a switch that is interconnecting between 2 of them. This type of network is called a flat network. Flat, because everything revolves around this network, right? But if you need to segment and break up this network, you need to introduce a router. You need to introduce a router. A router, what I mean by segmenting means if I want to create other networks out of this, right? I need to introduce a router. And creating other networks out of this is what we call subnetting. Subnetting. So I will start from explaining the different categories. I'm just trying to lay this foundation, understand the concept. If you have questions, I will, come back again. Okay. So the router normally if you have this box I'm drawing now represents a network, not a host. So this is network A. This is network B. Network. This is network C. There must be something here that will understand that any packet coming from within this network or within this network meant for maybe network C, it will actually be directed to network C. And it is the router that does that. However, the router will examine the network address of any packet that is coming from here and find out which host is the destination for that packet. A component of the IP address of that packet will have the network portion and the host portion. So, and the network portion will help the router to identify the network, and then finally, it will now identify the host, right? So the question is, how do we determine, how do we know which part of the IP addressing is a network, and how do we know which part is the what's it called, the host? Now, IP addressing is regulated by an organization. I think they are called ARPA or something. I want to remember what their name is. So they are regulated. They regulate the assignment of IP addressing at a higher level, and I'll explain what I mean by at a higher level, at a higher class, in the sense that we'll have where is this documentation here? Trying to, yeah. So there is a standard that is used to identify that. That is RFC 1878. It's just a standard. The organization is called, the organization that manages IP addressing on the internet. They are called Internic. This is the organization that determines the IP address that, you know, servers would have on the internet, right? Now, the classification of an IP addressing starts with class A. The highest class is class A class. The second one is class B. The third one is class C. We have the class E and class D. At this level, or this class of IP, they are like the highest level. At this level, you have thousands of network. You have access to a lot of network and hosts. Now, as you come down, the number of networks you have access to reduces, and hosts, and so also this way. So the body that regulates internet usually manages at this level, because at this level you have access to a large number of network. But at this level, you can manage it yourself. You can have a network of class C that, you know, you decide and assign within your network. And what you will understand what I mean by that. For example, the 192 IP address that I just gave is a class C IP address, and I will explain why it is class C now. So usually now I'm trying to see how to break it down. Does anybody have any question, please? Does anybody have any question?
Yes.
Okay, go on, please.
So you were saying that the IP address is assigned for like 2 weeks or something. So, but checking on that command prompt,
Mhm.
the lease, or is that the lease obtained and lease expires information?
Excellent. Excellent. You are very correct.
Okay, but in both cases, like on my laptop and on yours as well, I noticed
Yeah.
that it was just for, it's like for a few hours, like 2 or
Yes,
3 hours.
it's for a few hours. Yes, yes,
Okay.
yes,
So
yes.
is it that private organizations can make it longer, like
You
2 weeks?
can make it longer. When in my last company in Nigeria, I think our DSCP usually was set to 14 days. These are decisions. If I want to increase this on my own private network now, I'll just log into my router. I'm talking about the router that the energy provider has given me, or the
Okay.
network provider. I can log in there and increase this lease period. You understand?
Okay.
Yeah. So
And
yeah,
also,
go.
does it get recycled, like used again or something? I don't know if you get what
Oh
I'm
yeah,
saying.
yeah. After a while, you can have, if you have an IP address this month,
Yeah.
you can have the same one assigned maybe after 6 months again, because
Mm,
you have been, it's been assigned from a pool. So it's that pool now that I want to explain to us.
okay.
Right?
Thank you.
You're welcome. You're welcome. Okay. Any more questions, please? Um. All right. So let's continue. I I'm trying to be as simple as possible just to help us grasp all that I'm trying to say here. Um, so if you remember the first example that I gave, right? Um, the um, trying to break this thing down. Um, there are different ways of explaining this thing. When I started out, it was one of the aspects of networking that I had to sit down and understand. And even till now, when people are troubleshooting, they can find it difficult with IP addressing. When IP addressing is not properly done in an organization, it can cause problems. So I'm trying to look for the best way of explaining it without jumping, ahead of myself. But are we following? I want to believe we are. All right. Um, yeah. So I want to, you know, explain how to identify the network portion of an IP address and the host portion of an IP address. Right. If you uh, remember, I had an IP address 16192.168.123.0. Or rather, let me change this to, it can be .0. .0 will be the network address. Um, let's say dot what now? Maybe .9. .9, right? So there is another component of IP addressing that helps us to split an IP address like this into the network part and the host part. And that component is called subnet mask. And the subnet mask just, uh, you know, is a part that you introduce into the definition of the IP address of a host to tell the host which network it belongs to, and to also tell others that this network belongs to this category of systems, right? And normally, the host goes in this form: 255.255.255. The highest subnet is this, and I'll explain why it is 0 later. Now, what this means is that from this side to this side is the network segment. Then these numbers, are the host. Now, to break it a bit further down, remember that this octet here is if you are going to convert it to binary, is 1111111 2 3 4 5 6 7 8. 255 is actually a 1111111. So what that indicates is that the number here starts from 0. That's 0000000 up to 11111. I mean 0 to 255. So also here, that is what this means. So anytime you see a 255, 255, 255, it tells you the network portion of an IP address. It helps to define the network portion of an IP address. So it means that if I need to write these network marks like this, I need to now put a dot here and say 1111111.1111. For the last one will be .0000. Right? So what the subnet mask does is to, tell us which part of this IP address is a network segment. Now, this first octet of this IP, this first octet, actually starts from 0.0.0.0. So from this base level, if you begin to increment, you will have 0. The next, incremental value you get here, or rather, let me start from the left. From 0 to 120, give me a second. I think it's 127, 20. Pardon me. From 0 to 127, I don't want to. Give me a sec. It's I want to get it from my notes here. Yeah. Okay. Yeah, it's 127. So from 0 to 127, 127.0.0.0 is considered a class A IP addressing, right? So the next categorization, that will be from 128 up to 191 will be considered a class B, 191. Will be considered a class B category or IP class. Then from 192 to I think 192 to, let me check it up here. 192 to 1. Yeah, 192 plus C is 192 to what is, yes. So the 192 to 224, 224. So the class D starts from here. No, 223 rather. The class D starts from 224 to 254. And then at this level, the next number will be 255. 255 is a number you don't use because it is 111111. I'm not sure if I've explained myself well enough here. Does anybody have any question? So just to break it down a little bit better, class A is equal to 1.0.0.0 up to 127.0.0.0. And then class B is equal to 128. It will start at a level after this. 0.0.0 up to 191 point 255.0.0. Need to move this way, right? For the class C, you can ignore class D and E. It's not usually used because the number of network and hosts you get there is really very small. For the class C, it starts from 192 point 1 I don't want to jump above myself, but I will explain it now. Let me just, it should start from here. It should start from 192, 192.0.0.02 all the way to 2 to 223.255.255. Now, I want to explain something. Between these classes of IP, we have the public IP and the private IP. Public IP means what the general public shares. Private IPs are the IPs that you are allowed to assign to your network, right? So the organization I told you regulates these IP addresses. There are segments of this IP address range they've classified as public, and there are segments that they've classified as private. What it means is that you cannot assign those public IP addresses to yourself. You have to buy them. You have to buy them, and it is across the classes. So usually the private IP address is what organizations use within their environment. But if they have resources that are going to be exposed to the internet, if you remember last week when I was setting up the VM, there was a public IP address that was assigned to my VM. And it stated categorically during the creation of that IP address that I am going to be paying for it. Because public IP address indicates that it's like having a private mailbox. For you to have a private mailbox, you need to pay for it, right? So yeah, that is the difference between public and private. Do we have any question? Do we have any question? Okay. I'm going to give us some resources to help us subsequently, but let me go down now and explain how this addresses.
Sorry, Raphael. My question is on the IP addressing. When you started from the class A, you want 1.00 to up to 127.00. Then when you now go to class B, where since it's
yes, I jumped. You mean this one? You mean this one?
Yeah, it now got to 128. Now under where you now up to, it now became 191.255. How did 255 come in now?
Okay, very good. That's a very good question. Now let's break it down. I will explain it to you. Each of these segments is called an octet. It's called an octet. An octet means this is actually in binary. Remember that in binary it's 8 digits. So if I'm going to write this in binary, it's 8 digits I'm going to write. 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, if I keep writing this thing in binary, I need to keep changing the combination of these numbers. And in decimal place, it is like moving from 0 to 255.
Okay.
Do you understand? Because the maximum bit that will be on each octet is 1111111. Are you getting it now?
Okay.
That is allowable. Remember that there are portions of this range. Anything between here are numbers, right? So in the IP addressing scheme, 255, you cannot use 255.
Okay.
Because what 255 means is that it is a broadcast IP. What it means is that is what the switch uses to. Remember, I said ones and zeros are like voltages. So if you have a 1111111 on a port, it is like an announcement kind of IP. The switch is just saying, it's just broadcasting to all the ports. Do you understand? Right? There is no specific port that has a destination for that packet. I'm drilling it down to the level of how the packet is interpreted, within the devices. Do you understand? So in the computing world, 255 is not a number you assign to yourself, but each of these number progresses, like this one, for example, starts from 1 to 124. As it moves, the number starts from this. As it moves from here to here, I mean, the network segment starts from here. If you move from 1 to 124, 27 rather, which is class A,
yes,
right? It tells you that you have, if you minus 127 minus 1, you get 126. It tells you that you have 126 networks, and then every other thing here is host.
Okay.
Are you getting it?
Okay.
For the class B, the class B starts at 128, and then it will progress like this, like this, like this, like this, like this, until it gets to 191. And then the next portion is 255. Do you understand? The next segment, the next network segment is 255. Is it clear or it's confusing?
Is that 255 I'm talking about now?
Now that 255, right? Remember that you are moving. How do I break it down? Now, the when I was reading up these different documents gave me different interpretation. I'm coming. Just give me a second. Could I explain these things better? Um, 128, then now the 255, right, is, remember it's a classification we're talking about.
Yes.
Do you understand? It's like you're saying that range of numbers between from so to so, will be under a class. Range of number, from another level to another level will be under a separate class.
Yes.
Are you following now?
I'm following.
So and remember that if you are trying to identify the network, you start from the left, not from the right. Do you understand? You start from the left and not from the right. And then also, we have a graduation of the numbers, in which case anything that is identified by 255 tells you the network number. I don't know. Is there anyone in the class who can help me explain it better to me? Is this who is asking? Is that Igwe?
Yes, sir.
Oh, okay, Igwe. Emeka, you are here in the class. Can you explain it better for me to him?
I think you are doing a great job.
All right. Igwe, do you understand? Or you still want me to, you know?
You know, while I asked that is
Mhm.
from the classification from group A to B to
Mhm.
C classes of IP addresses.
Mhm.
You know, when you started with the one like that. Then when you got to B, you got to C. Now you now had 192.0000, and you when you now see you're moving from the right to the left. Now you now go to that 191?
Mhm.
Instead of the 000, you now had 225.0. So I'm not saying how did that 225 come about? Why
It's
not 0?
okay. You are wondering, okay, why not 192.0.
Yes, there. Yes, yes.
I get your point.
Oh,
Why?
okay.
Okay,
My
why not?
student, okay.
Okay. Emeka, you want to say something?
No. Go ahead, please. Go ahead.
Okay.
Maybe after you. After you.
Yeah. So now, what that means is that um, I'm just looking for now within this range of this network, right? Within the range of this network,
Okay.
we have segments that are public
And private.
and private.
Yes.
Do you understand?
Yes.
And so, even though you have, it should be 128.0.0.0 to 191.255. Sorry, according to your understanding, it should be 0.0.0, right? The thing is, you need to realize that as you move from this network, you are moving upward up to the next level of the network. This first octet identifies the network, and as this number graduates, it progresses. Now, within the first octet, remember that for the public IP addressing, right?
Okay. Okay.
For the public IP addressing, the next range is 192.255.0.0. It is like this is what has been taken. You cannot use it.
Okay. Okay.
Do you understand? It is like
Okay.
it is like a portion that has been reserved for the public, and if you want to assign it on your network, you cannot use it.
Okay.
Do you understand?
Okay.
But within it also, for the class C now, remember that we are talking about class C, right?
Yes.
For the class C now, we now have a private range of 172.16.0.0 up to 172.31.255.255. This is a range that is classified as private and is still under class C.
Okay.
Well, private because if you want to assign it inside your organization, these are the ranges of IP addresses that you have access to.
Okay.
Is it clear now?
Okay.
You know, I mean for the class B, pardon me. For the class B. This is class B, not class C, sorry.
Yeah. Yeah.
It's class B, not class C. Okay, I can start from beginning again. Do I start from beginning? Is it clear now? Or
Can I add something, please?
Yeah, go on.
Okay. Is it possible for you to bring up that a JPEG file that you have on your WhatsApp?
JPEG file on my WhatsApp.
Yeah. Some IP address.
Okay. Emeka. Okay. All right. Let me get it up.
Okay.
Let me get it up.
The little thing I want to add is that the 255 represents means that the binary value there is they are all ones. So if they are all at the time they are all ones, it does not transmit data to anybody's. But the identification body that has demarcated the different classes is a rule. So that's why when you want to use your IP address as an organization, you will have to acquire it from the company that will provide it to you. So it's not something you can buy from any particular shop. You have to be licensed to get it. So every one that wants to get it, we have to decide, okay, this is the class of IP address that you want to get. Now, for class A, B, and C, they have specific bound that has been range that have been given, like Raf has already explained. When it comes to the 255, it says this 255, if you convert it to binary, it means ones. All the values there are going to be one.
Okay.
So if I have another set of numbers, say for example 128, if it's converted to binary in 8 digits, it will give me ones and zeros, which will represent a particular information. But at any time the octet is defined as 255, it means they are all ones, and the network sees that particular octet as nothing. Hence, the body that defines the IP address now has placed 255 as the value for broadcast. So at any point in time, you want to send out information to everybody on the network or in a group of network, 255 is what is used to push out that information. Now, to close up each of the classes, so class A or class B, you will notice that when you set up the subnet mask, when you set up the subnet mask, you have probably for class A, you have probably 192.128.6.255. So you're saying that the fourth octet is closed. So I have just three octets that have actual data. So the data in the fourth one is I don't know if Raf, if you show that
it's still loading.
Okay.
But I think I have another. Let me use this one.
Yeah.
We can use this one too.
So that the full picture will be there. You can now demarcate between, okay, this is how class A is, this is how class B looks like. Then you can now see okay, oh great.
Yeah, so I just pulled up this one, right?
Okay.
I've dropped the link in the chat. Now, just to add to what Emeka is saying, the class A is the top level classification, right?
Okay. Yeah.
And at that level, it's starting from 1.000 up to 127.0.0.0, right? What this indicates is that you have 126 networks. Because if you say 127 minus this, right? 126. But and that is a public segment. That is a public segment of this classification. The The private segment now starts from 10.10.0.0.0 to 10.255.255. Is it clear?
Okay.
Okay, let me explain it again this way. That this document, I will just put my screen here so you understand what. Now, this class A, let's look at, remember, just put this at the back of your mind. Every class of IP addressing has the public range and the private range. The public range says that you cannot touch this range of IP. It is designed or assigned to the public. Assigned to the public means that is what the everybody on the internet is using.
Yes.
Right? But for the private, you can use it in your internal network. Right?
Yes.
And your internal network is not the external network. What I mean by external network, that is public network. That is the internet, right? But the class A categorization is just telling you the number of networks that you will have access to when you decide to use a class A addressing scheme. You will have access to more networks, more hosts, fewer networks and thousands of hosts. Do you understand?
Yes.
And that thing that defines the host is now the 255 that Emeka mentioned, the 255 octet number. So now if you look at this statement here, it says the first octet value range from 1 to 127. And so if we have 1.0.0.0, this number will move like this to 255 before this one becomes 2. And so it will keep moving 255. The last digit will always be 255 before this one becomes 3.
Okay.
Do you understand? So as it keeps moving, this when this now gets to 255, you now get to the next level like that. Okay. Are you getting the graduation now?
Okay.
Right. So if you look at this, it says that the private range is from 10.0.0.0 to 10.255.255.255. Do you understand now?
Which is the ceiling. It can't go beyond.
Yes, you can. This is the maximum. That's why it's all ones. You understand?
Okay.
Do you understand now? So this 10.0.0.0 is actually between is a range between this number, because if you look at this number, this number 1.0.0.0 up to 127.0.0.0, the 10.0.0.0 up to 10.255.255.255 is embedded between that overall range of this one. Does it make sense?
Yes.
Do you understand now?
I understand.
So inside this class A addressing scheme, we have a 126 networks, but the range between 10.0.0 to 10.255 is reserved as private. You understand?
Okay.
Mm-hmm. Is it clear now?
It's clear.
Oh, yeah. If you understand this, frankly, you have understood computing. Because I can tell you, every day people get confused with IP addressing. in a normal work environment, even when you're troubleshooting, you want to start, okay, how is the IP addressing but so looking at class A now, you will see that there are 126 networks, like I mentioned, and you have 16,777 hosts. So class A gives you more network, few networks, and larger number of hosts. That is why class A is more for the public internet. Are you following now?
Okay.
Now, if we scroll down to class B, remember that this stopped at 127.
Yes.
Class A stops at 127. For the class B, it will start at 128.
128. Yeah.
Then it will also progress from 128.0.0.0, it will keep going, incrementing, up until you get 0.0.255.191. I told you that it increments from left to right, left to right. You are already used to incrementing from unit to decimal, so don't use that.
Okay.
Don't use the normal incremental value of units, tens, thousands, millions that starts from right to left. You know what I mean?
Yes.
In this case, for this addressing, it's incrementing from left to right. Because remember, the start is 1.0.0.0. This is the start, the beginning. It starts from here. It doesn't start at 0.0.0.1. Are you following now?
Yes.
So if it's incrementing from left to right, it means that this is what we change. So what this means is the next number after 128.0.0 will be 1, 2, what would that be now? 1, 2, this will come as 0.0. The next one will be what will be the next one? It's why it's a bit confusing is because we're doing octet, not the binary. Remember, just know that in your mind, it's binary that the computer knows.
Okay.
You understand? So if I should break this down in terms of binary now, maybe it would be easier if we let me break it down. So this one, 128 in binary is what? I just hope I've not confused people today.
What's in here? What boy? What's in the binary?
Let us stay on the number. I beg, don't go binary. I want to complicate you.
Okay, if I don't do the binary, you won't understand it, So the binary for 128 is 1, 0, 0, 0, 0. I think Emeka has dropped it in the chat. Is that 10 million? 1, 2, 3, 4, 5.
Make it 8 digits, 1 and then 7.
Okay, thank you. 6, 3, 4, 5, 6, 7. So 128 is this dot 1, 2, 3, 4, 5, 6, 7, 8 dot. Like this. 1, 2, 3, 4, 5, 6, 7, 8 dot. One, 2, 3, 4, 5, 6, 7, 8. Now, because it's incrementing this way, the next number here will be 1, 0, 0, 0, 0, 0, 0, 0, 1 dot 0 dot 0. So it will keep incrementing until it gets to the next, until it gets to the next. Is it clear now?
Yes.
Do you understand now? So it's the octet that increments first. Before it goes to the next octet. Before it goes to the next octet. Octet is just the set of the 8 digits. Is it clear now? So that's why we have it as 127 to 128. It's because it will increment like this until it gets to 1, 1, 1, 1, 1, 1.
Yeah.
You understand, right? So until it gets to that 1, 1. So the IP addressing range now, which is being, now this now shows you 128 to 191.25. If you see 255, just know that it's 1 in 8 places.
Okay.
Are you following? If you see 255, just know that it is 1 in 8 places.
And that's the ceiling. They can't go beyond that.
It can't go beyond that because the 1, and you cannot also assign 255 as an IP address to a host, because it's a broadcast IP. What that means is all the ports will just flash 55 volts, 55 volts, 55 volts, and the switch just will hang up and your network will freeze. Do you understand?
Yes.
So I would like. Yes. Go on, please.
So that 255, is it as long as 255 appears in any of the octets, right? Not like 255 all through.
Oh no.
I don't know. Okay.
Yeah. So what we're saying is that this 191 to 255 defines the network.
Yeah.
Do you understand? So if I have now, I told you that there are 2 components of the IP addressing scheme that. This is what I mean. If I have 192.255.0.0, right? This is a public IP. This subnet max is what will tell me that this is a class A IP address, class B rather, because I have a ceiling here, I have a ceiling here. Are you following? So it is this subnet max. You cannot assign network address to a system without a subnet max. You must have a subnet max. If you look at my own terminal, right, there is a subnet max there. It is just like brother and sisters. They move together. Do you understand? Because the subnet max will tell the computer or tell whoever is trying to discuss with the computer the network segment that host is part of. So if you look at this, 255.255.255 tells you that everything from left to this point is the network. And this 0 is the host segment. Are you following now?
Okay.
Right. So yeah, go on.
And this yours looks like class B because I can see 192 dots.
It's a class C.
B,
because
right?
it's class C because it had
C,
168. Okay. Yes. Let's go back and verify. It's a class C. Class C starts from 192.
192. Okay, it's class C. Yeah.
To what? For the private. Can you see now? This is a private. Private means it is in my house. I can assign this. There is no way. If I try to assign this IP address on my network, I will not be allowed because I am not an ISP. It's only ISPs that use this range of IP because they have thousands of users or millions of users, so to say. Do you understand now? So, and that's why they say public. Public means you are facing the internet. Do you understand? But for me, I am accessing the internet quite all right, right? but I have a gateway. It's like a door. It's like a security man that determines how and when I would access the internet. Do you understand? That gateway is my router.
Yeah.
Your modem, the modem in your house provided to you by the network provider, it serves as your router, it serves as your gateway, it serves also as your DHCP server. So the router actually serves multi-functions. Do you understand? These features are a progression of technology advancement over the years. Before, you need to have a separate DHCP server on a network. You need to have a separate gateway proxy server, and then you need to have a separate router. Do you understand? But now, everything, because of the advancement of technology, everything is now condensed into one device. So the modern devices now have those three features, functions: DHCP to assign IP addresses to the host with an expiration, serve as a gateway. It means that if you look at this IP, the gateway IP address is 192.168.1.1. So my router's IP address is this. Are you following now?
Okay.
Do you understand now?
Yeah.
And you can see that the DHCP server also carries the same IP. So it shows you it's the same device that is serving a function as a gateway and a server, a DHCP server. Do you understand?
Okay.
So
Okay.
this router receives the packet from my system, and then the router will have an outward facing IP address, a public one, to which it will push all my packets. Do you understand? You cannot see that here because the router is sitting as the head of my network. Are you following?
Okay.
So the router is sitting as the head of my network and as marks any IP address that is out there. I cannot see it from my system, but if I log into the router OS, the router also has an IP address. If I log into it as a device, I will see the public IP address that is assigned to that router. So what the router does is that it routes packet, the Americans would say routing. Is it clear now?
Yeah.
So I just want us to, I've dropped the link to this IP addressing scheme in the chat. If you still think you don't understand, you want me to take you up on it again, I can, do that. But I feel that it's important that we understand the IP addressing scheme. Now, if we come down a bit, this is a summary of what we have been saying. Class A, starting from 1.0.0.0 to 127.0.0 is a public range. In between these, we have a private range that starts from 10. Remember that 10 is between 1 and 27.
Yes.
Do you understand? Right? So inside this public range, we have a private range that you are allowed to play with. So if I want to assign a class A IP address to my network, let's assume that I have millions of hosts. I am a very large organization, like maybe, I don't know, a very massive organization like a star links, for example, that deploys satellite for internet. They might want to use more networks, so between here and here, they have access to play around with their private network. Any organization too can use this range, but anything outside this range you cannot touch. Somebody has to approve it for you, and the organization that does that is called Netcar, like I showed us earlier. So the subnet mask This subnet mask is what defines the categorization of the IP addressing class. The 255 here tells you that this is a class A IP address 10.0.0 to this. So this is the network segment. This other segment is the host segment. Between here and here is the host segment. Are you following now? But remember that you cannot, usually there are reserved IP. You cannot assign the first and the last one. So in this private range also, you cannot assign 10.0.0.0 and you cannot assign 10.255.255.255. You can only assign the numbers in between them. So for example, the maximum number you can assign here will be 10.255.255.255.254. The moment it gets to the last one, you cannot assign it. You understand? So, and here it shows you the number of networks and hosts. You have 60 million hosts here that you can assign. For the class B starts from where this ends, 128, up to 192. But in between these also, we have the private range. So the private range, I can do a screenshot of this for us. Okay, I'll drop it in the WhatsApp later. Okay. So that is I'm sure those who didn't come to class today will wonder what is happening. All right, so that is just a breakdown. So for the class B, it starts from 128 to 191, right? Remember that it's graduating, and moving upward from left to right. So when this one got to 191, the next field 1255, right? In between this range, you have a private range, which is 172.16.0.0 to 172.31.255.255. And the subnet max is starting from left to right. 255.255.255. Next week, there is, where I'm going to pause soon. There is what we call subnetting. Subnetting talks about breaking, network into several networks. I will explain to us what subnet. I thought I could go that far today, but I've not been. The time is gone now. So, but for the class B, the number of networks you have here is now more. You have 16,000. And then you have hosts of about 65,000 hosts. So what this indicates is that you can assign IP addresses to as much as 65,000 devices, nodes, systems, anything. And remember that in networking, I've talked about virtualization. You can imagine how you have several virtual servers. Like I remember in First Bank had close to about 2,000 virtual servers running at a time. And so those servers would have their own IP addresses. With virtualization, with cloud computing, you can have as many as 60,000 addresses, hosts. You can have your containers, like in Kubernetes now, we have containers that manage application, so you can have several. Class C is the most popular one that people use. You see that my own private network is a class C, and it starts where this one stops, 192 to 223.255.255.0, right? In between the range of this public IP, we have the private one. You understand? We have the private one. And the subnet mask also helps us to define the network segment. So what this tells us, if you read it from left to right, tells you that 1, 2, 3 is the network. So you have more networks now, but fewer hosts. So the more you go up, the more network you have access to, and then the less host that you have access to. So subnetting is where you split up these networks. You split it up. I will explain to us next week about, I think we'll just pick up from subnetting next week. I would like to stop here. Does anybody have anything to add? Emeka, do you want to add anything? Vince, do you fully understand? Mariam, I didn't hear your voice today. I hope I've not confused you. Sumisola, Amusan.
So if you can go back to that chart, last one you did.
The chart, okay.
I just want to point something out there. Yeah, this one here. To really understand, just to throw more light on the host per network.
Yeah.
If you look at class B now, you see 255, 255, then the last 200. You know that just as you explained, the maximum we can have there is 255. Okay, let me take the last one. The C. You know, the first 3 has been taken, which serves as the network. And the last one, 0. Then the maximum you can have there is 255. Minus 0, you'll be left with 254.
Yes.
That's how you got that's how we have the host becoming very small.
Yeah.
As the have becoming very small, which is 254.
Yeah.
Then in the class B, you have 2 zeros. That's the last 2. Okay, then if you multiply this 254 by 254, you are going to get this 65,534. So that's
Vince has brought in a bit of mathematics into it. So just multiply the 254 times 254 times 254 here, and then you get
yes, you get that one. That's true. Yeah.
Right. Thank you, Vince.
Thank you, Vince. I've learned something now.
All right.
Actually, it was an Indian guy that taught me this. But apart from even the knowledge, the language is my challenge. That's why I said I enjoyed this class more than all the ones I've done before.
Okay, yeah.
It could be very good, but the language is also a challenge.
Yes. The IP addressing can be explained in different ways. In trying to prepare for this class, I went through, documentation from Oracle, from Microsoft, from Cisco, and each one of them started at different level to begin to explain it, right? So that's why it's good for someone who understands it and knows it to teach it, And for me, when I started out, it was quite difficult for me to understand, this level of networking, because if you don't understand this, you will not understand subnetting. Next week we're going to take subnetting, and then when we do subnetting, you easily now, when I say design your network, because I'm going to give assignments for people to design their networks and assign IP addresses to them, right? And you're going to design your network in Azure and build resources and deploy it in Azure. So let me see if I can log in. Would this allow me here? I wanted to show us something on VNet, where it will tell you to give an IP address. That no, I don't want to do this now. So yeah, that's just it. So I want to thank you all for coming tonight. Any question? Any question?
Just for classes D and E, they don't have subnet mask, right?
They do. They do, but usually, of course, the subnet masks will keeps increasing, but subnet D and E are not in use. People don't use them.
Okay.
Do you understand? Let me show you. They are not in use because you have far less number of networks to use at that level. Right. In fact, there is no network available. There's no network available. Can you see it? For class D and E, there is no network available. Can you see? Not available, not available. So all of these are used, the multicasting. This is left for research and experiment. So like I mentioned at the beginning, when the IP version 4 addressing scheme started running out, because you can imagine how, some segments are reserved for public, some segments are reserved for private, right? It means that what is left in the public is actually limited. So they had to upgrade to IP version 6. That's why we now have an IP version 6, and the form of IP version 6 is even more complex. It comes more as a hexadecimal. This is hexadecimal, not binary. The other one, remember there is decimal, which is the normal number we know, right? This is decimal, or in form of octet. This is hexa now. This is hexadecimal, and with it you have millions of iPods. I've not seen I've not seen any host with IP address versions, and many times network administrators, they turn off this feature because people are yet to understand how to use this in their environment. So for now, focus on IP version 4.
Then, with respect to Vincent's or Vince's suggestion on multiplying, is there like an additional element to it? Because it doesn't give that full figure, although it's in the neighborhood.
I would not say, just to explain it a bit more, really not. Okay, so let's look at, I want to break it down a bit for you. Now, let me take this one, for example, right? If you have, let's say, a private IP like this, 10.0.0.0, that's 10.255.255.255. Remember that I said this increases from left to right. Between this number 0 in decimal is 0.0000000. 1, 2, 3, 4, 5, 6, 7, 8. 2 raised to power 8 is what? 2 raised to power 8 to factor 8, right? Is that 256, isn't it?
Yes.
256,
Yes.
right?
Yes, 256, yes.
Yeah. So 256. 256. Now, in computing, the first digit 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. You cannot use them. So anything in between is now the 254, because this is now minus 2 of what you can use. Is it clear now?
Yes.
So usually that's how I tend to this, if you are going to explain it electronically, you understand, in terms of signal, zeros and one, because to the computer 0 just means dead. Do you understand? And one means confused state. Do you understand now? It's like one means anytime you see your computer hanging, they say my computer is hanging. Your computer has entered a state of either ones or zeros. It's confused. The only thing computer understands is a combination of zeros and one in any order. Are you clear now?
Yes.
So for the IP addressing, this is how you look at it. So at this point now, just know that it's a 256 host per range between this level to the next 256, but I can't use the first and I can't use the very last, which is 255. So it means what I am allowed to use is the last digit, the last host will now carry a 254 IP address.
Okay.
Is it clear now? So it means for this range, the last host here before this final one will carry a 254.255, like that. The moment it gets to 255, you can't use it because that's like the maximum.
Okay. Thank you.
You're welcome. All right. Thank you all for making it tonight. I hope it's been exciting. Please don't get scared. That's why we're here. I would like to introduce Emeka. Emeka is a very close friend of mine. He's a Scrum Master by training, by design, by makeup. So anyone interested in Scrum, you can reach out to Emeka and he will guide you. He hosts his own class separately. You can reach out to him for details about that. By God's grace, in February, my friend Ewere will come and take the class on security. I also have somebody coming to take the class on data engineering. Then for Ewere's class, it's going to be on Wednesday, the first Wednesday in February. So his own date will be Wednesday during the week, just for us to know. I will maintain my class on Saturday. The other person, I've not agreed with him yet on the day he would want to choose, but I think that having each facilitator taking different days will be helpful, so we don't, it will help to streamline your skill. If you choose to just attend my own class, it will be easier, for you than to want to juggle security. You are juggling security, you are juggling other aspects. I will focus more on AI after this foundation level. So I will take AI. Ewere will take security, and the other man will take data engineering. All right. There is a cloud architect that I can also bring in later, but I've not discussed with him yet. Remember that there is no money involved in this class, so I want people who will be willing to give their time, right, for nothing, right? All right. So thank you very much for keeping a date. I'll put the recording on the YouTube channel. I will also encourage us to subscribe to that YouTube channel, so you get notification when any video is uploaded. Okay, thank you all. Have a good evening. Enjoy your night all. Bye-bye.
Thank you. Good
Thank
night.
you. Bye.
Yeah.
Bye.
Good night.
Good night. Good night.
Thank you.
Thank you. Bye.
Thank you.
Thank you very much.